One of the misconceptions that people have about asymptotes is that you can't cross an asymptote. Well, that's not true. Um, Vertical asymptotes are places where the function heads off to infinity, and it's not even defined at that point. So no, you will never cross a vertical asymptote. Horizontal asymptotes are a completely different beast, however. Here's an example of a function. I'm going to factor the numerator. I got x times x squared minus 9. The x squared plus 4 doesn't factor in the denominator. Uh, but I can factor this a little further. So I've got x times x plus 3 and x minus 3, because that was a difference of squares there, right? So x to the fourth plus 1. Okay, this tells me a lot of stuff about the graph. Okay, it tells me it's got an x-intercept at 0, it's got an x-intercept at 3, it's got an x-intercept at minus 3. Each one of these factors generates an x-intercept because they would make the numerator equal to 0 and hence the whole function equal to 0. Okay. The denominator would be creating vertical asymptotes, but the denominator is never 0. So there's no vertical asymptotes. If I look at the limit as x goes to infinity, this x cubed minus 9x over x to the fourth plus 1, biggest power on the top is an x cubed. Biggest power on the bottom is an x to the fourth. Canceling out what I can here, this looks like a 1 over x, and that's going to go to 0. So this tells me I've got a horizontal asymptote of 0. So as x is getting big, it's going to 0. Well, I mean, the power in the bottom was bigger, right? There's a fourth degree on the bottom, the third degree on the top. So the top is going to be growing faster than the bottom is going to be growing faster than the top because it's a fourth degree polynomial, and that's only third. So that denominator is going to dominate. Pull it down to 0. Dividing by a big number makes the answer small. I'd also notice that when x is really big, these are both positive numbers. It might be negative for small things because of this minus 9x, but when x is big enough, this is going to be so much bigger than 9x that this will make it positive. So I was trying to decide, do I come into 0 like this, or do I come in from underneath? And I had to decide, yeah, I'm actually positive. So it is coming from the top side here. There's an intercept there, so I got to go through that. There's an intercept there, I got to go through this. There's an intercept there, I got to go through that. And then there's a question of what happens as x goes to negative infinity. Well, it's the same thing here. As x is going to negative infinity, it's still an x cubed over x to the fourth. It's still behaving like a 1 over x. Well, that's going to 0, but it's doing it from the negative side, right? The denominator is always positive, but the numerator, when x is negative, x cubed is also negative, and so that's going to be negative. So I'm coming into 0 from underneath this time. Okay. So this function looks like this. Notice, it's got a horizontal asymptote of y equals 0, and yet it crosses y equals 0 3 times. It's okay to cross horizontal asymptotes. Here's another one. Here's a function that we looked at before. I want to do the limit as x goes to infinity of sine x over x. We looked at it as x goes to 0, right? As x goes to 0, the limit was 1. There's a hole right here, but this function was coming up to 1 from both sides. Well, I want to know what happens as x goes to infinity. Well, this is a sine curve with an amplitude function. I think of it this way. Just think of it as multiplying by 1 over x. So this is a sine curve with an amplitude function that's 1 over x. The bigger x gets, the smaller the amplitude. But it's still going to be going up and down. It goes up just a little bit, and then down just a little bit, and then up just a little bit, and then down just a little bit. Right? This limit is equal to 0. As x is going to infinity, the sine of x stays between 1 and minus 1. But then you're dividing by a bigger and bigger number. So you got a reasonably small number divided by a really big number. That's going to be small. Right? And the horizontal asymptote here is at y equals 0. Likewise, on this side, as you go to minus infinity, it keeps going up and down. It keeps going below and above and below and above. But each time you go less and less. And this does have a horizontal asymptote of 0. This function crosses the horizontal asymptote infinitely many times. And yet we still call it a horizontal asymptote because that's what the function looks like. If you zoomed way out, well, sorry, not if you zoomed way out. If you moved yourself sideways on this thing, you keep going. I can't go sideways in this picture, but if you keep going off in that direction, more and more the function will look like it's just the line y equals 0, right? Yeah, it's actually going up a little bit and down a little bit and up a little bit and down a little bit, but so little you can't tell. And the closer you get to infinity, sorry, the more you tend towards infinity, um, the harder it's going to be to distinguish the actual curve from the line y equals 0. So there's a horizontal asymptote, and you cross it infinitely many times.